Here we go. So, any questions before we start? Now a poll is out, and then you see if that exactly good. So if you have a question, you say yes. Then I'm gonna say, Elizabeth, tell me what's the question.
I just have a question about the workshop.
Uh huh.
There was an issue in the main CPP where there was a constructor, I believe, with two arguments.
Yeah, I responded
But
it on Teams. There is no issue.
oh,
You are creating a three argument constructor, and the third argument is supposed to have a default value of null pointer, null
oh, I
PTR.
see. All right.
Therefore, it acts like a two argument constructor and three argument constructor at the same time. And thank you for the
Okay.
question. So,
Okay.
everyone who have problem with two argument constructor, please take a look at that. I can extend the due date for the workshop because we are having a lecture. You want me to do that? So you can submit it to, like till like 2 3 hours after the class or till night.
Yeah. Yeah,
Okay,
that'd be great. Thank you.
I'll do that.
Yeah, please.
I have to do that now because before I forget. So so I'm not gonna make it as an extension. I'm just gonna uh, wait a minute. So workshop 4 we are talking about, right?
Yes.
So workshop 4 lab. I am going to extend the due date till 23:59, and I'm gonna do the late one by tomorrow, say noon. Is that okay with everyone? Okay, so you have till midnight to uh and in here I have to go for the other one. I have to say, you know what, I'm gonna make it to 12 o'clock midnight tomorrow. That's better. So like that, it's easy. So 12 o'clock tonight and tomorrow because I wasn't in class and we didn't do it in class. And somebody said it's not okay. Why you're not okay? You want me to do like you don't like the extension? What's going on? Irvish, are we
I
good?
did it by mistake.
Oh,
I
you
did
did.
it by mistake.
I thought you said no. I don't want extension. I want to submit it now. Okay, so this is
Yeah,
I'm
I
gonna.
am going to.
Okay, good. So I'm gonna save it. File save. And please confirm, do a dash do and see if the due date is extended, but reflection stuff remains the same. And let me know if everything is good. Okay. All right. So that's that. A few other people said yes when I said you have a question, and I missed that in the other poll. Could you please tell me what was the question? So I'll ask one more time. Do you have any question before I start? Sorry. There we go. Okay, mostly say no. Manny, Kwa, Kushil, and Ali did not respond, and also Rish. So that's that. Anyways, so let's begin. Make sure everything's getting recorded. Yes, it's getting recorded. So we talked about operators. I'm going to quickly go through the operators and uh, make sure everything is good. Before that, let me put my phone on silent, and I would set I would set an alarm. So the class ends, if I believe, at 12. Let me just bring it up. It should be in the content. So if I go to notes, I should, oh, not notes. If I go to in-class notes, I should have the schedule there. So the class ends at 11:35, and 11:35 we're going to end. So because I don't have to go to any other thing, I'm just going to quickly set this one. So I'm going to say set an alarm for 11:34 a.m.
Okay, it'll go off in 1 hour 31 minutes.
Fantastic. Okay, so just to remember that I have to end by then, and that's that. We can get rid of this. We don't want this. So we talked about operators. So we start categorizing the operators, and we said, giving you an example of operators, I have a type. If I have A type, B type, C type, and A1, B, and C are the types of the objects of type A type, B type, C type, we can categorize operators as follows. We can say I have a binary operator when the operator sits between two operands. So A and B are operands, and the at sign over here is the a placeholder for any operator. And we said binary operators are operators that sits between the two. So essentially A plus B that I have over here, it sits between the two. And what it does, it gets the left and right operands as arguments, and it does something to it and returns a value. So any operator binary and not any binary operator, any standard operator in C language returns a value. And when I say standard, is that not the overload, but the standard. So any standard operator that you have returns a value. So if you have a binary operator, the binary operator does something with the two operands and returns a value. In this case, we talked about because this is greater than, it gets the left and a right, and the content of these two will be essentially 3 greater than 4, and that's false, and false is 0, so A becomes 0, so on and so forth. And these were the examples that we had from binary operators that we have in C. So are we okay with binary operators? All right. So because we've already went through this, I'm going to copy this. I'm going to copy this operators.txt in today's lecture. So I'm going to put it in today's lecture, and I'm going to add a few more things over here. So we know now that we can overload operators as functions, and I'm reviewing it, so I'm adding a little bit of more information on over it. So when you have any type of A is B at C, okay, when you are overloading a binary operator as a member, that binary operator is a member of the left side class, receiving a right side class, returning whatever that is being returned. So therefore, the representation of this operator will essentially be a B type operator at that receives a C type and returns an A type. Now, please bear in mind that C type and A type could be anything. It could be a reference, it could be constant C type, but it is a C type. It's either a reference or it's a constant reference, but it is a C type. So this is what we call a general signature for, let me put it at the top of it. So this is a general signature to implement signature for implementing a binary member operator. So that's how it is, and we'll come back to that later. We're going to take all these things and set it aside, and we can use it as a blueprint to do whatever we want to do. So we said that, so this is a general type for it, right? So we say if the B and C remain the same after the operation, if B and C remain the same after the operation, we say that, what do we say? Can everybody say? We say that the operator has no
side effects.
Perfect. And that was, oh, I should have removed that. I didn't see who. Get out. I want to see who said that. Sometimes the big blue button is too slow to respond. I wanted to see who said it so I can remember people who participate. So the operator has no side effect. Okay, which means none of them changes. If that is the case, then the prototype for the operator will be either this, which means C type is passed by value, it doesn't change because it's passed by value, or it is this. So you can use this as a blueprint. Const C type reference. So these two are overloading a binary operator that B and C remain the same after the operation. The operator has no side effect. Okay? Now, depending on if B changes or C changes when the binary operator is running, then you can change all this stuff. So if B or C change after the operation, the operator has side effect. Therefore, it will be either, so in this case, I'm going to write over here C type reference. This is if C changes. And remember, this never happens in standard binary operators. So you never have B plus C and C changes. We know that. So an example I do have for, like, the example for this is A is set to B plus C, where there is no side effect. I cannot give an example for this. There is no operator that changes the right hand one. We don't have such a thing. Okay? So this never happens in standard binary operator. But if B changes, then this is very normal. We have this. And if B changes, which that means this constant is removed, and we have either by value or constant reference, which means the right one will not change, but the owner, that is the left one, will change. An example for it will be A is B plus equal C, something like this. Okay, so these are the implementations for it. We're gonna put this thing in a table later on, and so you can actually use them as a reference if you want to overload, how you overload. So yeah, that's it. So no side effect. So in here I'm gonna put no side effect is this. This one is, I'm gonna say right side effect. is this one, and this one is going to be left side effect. So essentially, if you want an operator to have a left side effect, this is how you overload it. Okay, so we are done with review of binary operators. The examples for it would be the examples for it would be, they put something in my eye and I cannot see the screen properly, believe it or not. That's why I keep zooming it back and forth. My apologies if you see. I'm trying to see the name of the, so this one is without. Anyways, I'm gonna, so as you see, for example, this is the one that is doing side effect. You see it doesn't have const. Int is coming by value. Because it's by value, it doesn't change at right side. Therefore, this is left side effect. Okay, an example for it. Now you could put this thing outside of the class, so the implementation for outside of the class. So if I wanted to have this outside of the class, let's say minus equal. If I wanted to have minus equal overloaded, then it would be minus equal. And if I want to have it outside of the class, this is what I would do. So it comes over here, and we come outside of the class. This is the signature that I have written over this. So in here, I'm going to say container, again container, operator minus equal, int value, and then in here I'm going to say m value minus equal value, and return this. So this is exactly what I have written over this. So if you look at this, we said left side effect. If you look at left side effect, this is what I have. It returns a type. It belongs to the left operator. That's the operator, and this one is by value. So if you look at here, this is what we have. Okay, so I'm going to put this one in our session as a binary operator review. And we're done. Okay, so that's that. Let's go back in here. Any questions about binary operator overloads? Poll is up. Okay. So an example for right side effect is, say I want to, let's say I have two containers. Let's say I have two containers. Let me remove all the examples that we have in here. You know, you have them from the previous one. I'm going to take all these things away so it doesn't have too many things. So let's say I want to have a container A, and this container A has 20 values in it, and I have a container B. Okay, so I have two containers. Now I want to pour all the values of A into B using an operator like this. I want to say A, and I want to do this B, which means, for example, move all that is in A to B. So I am just building an operator. Again, don't think of it as the extraction operator that you use for cin. It's just an operator. I can overload it and give it a new meaning. So if I want this to happen, then it must have right side effect and left side effect because it changes A, removes the 20 out of A, and moves everything to B. So if I want to do that, the and I can return, so I'm going to have over here C, for example, or I can return the amount that is moved. So in here I'm going to say amount moved. So let's say it returns an integer. See, I'm just designing it on the fly. So amount moved. So when I have something like this, you will see that to see what you want to actually overload, write the operator version of it. So the operator version of this essentially will be this dot operator and then receives the B. So that's your signature. So this is what is called when the above executes. Do we understand this? Oh, one person said no. Please, if you are responding, don't wait for me to look at the polls. If you're saying no and you have a question, please ask your question. Don't let me go. Who had a question for the previous poll? Anyone? No? Okay. Now, are we okay with what I have written in here? I see it's delay comes with yes. I see people say no. That's good. So people who say no, somebody volunteer and tell me what you didn't understand, and I will explain it to you. Or if it's just vague, ask me to repeat again.
Professor, hi.
Yes, hi.
If you please explain it again, slow and more precise, I will be appreciated.
Okay, no problem, no problem. So I'm gonna put it.
Thank you.
Thank you very much for slowing me down. When I get excited, I speak too fast. So let's continue, but in a more uh, um, precise way. Let's say my application requires that I have an operator that I can move values from containers to containers. Just imagine that these two are two cups and I want to empty the content of cup A into cup B. And Muhammad, I want you to stay on uh, call because I want you to respond if what I'm saying is clear, okay? And then everybody else will understand it too. Okay?
Okay.
So assume A is a cup and B is a cup. A has 20 cc's of something in it, and I want to pour the 20 cc's of A into B. Now to do that, this looks like a good operator because it kind of shows what goes from A to B, right? Now, if I have something like this, I would like my operator to look like what I'm writing over here and say after this operator is executing, I want to see how many cc's of liquid from A was moved to B so I can do something with it. So I like this operator not only to move the liquid from the cup A to cup B, but also tell me how many cc's of liquid were moved. Does that make sense, Mohammed?
Yes, please.
Okay, if that's the case, then we know that any operator that needs to be overloaded and it's binary, this is the format for it, which is essentially I have operator belonging to the left operand receiving a right operand. April, mute yourself. Okay, thank you. All right, so then after doing this, so now I have to write down the signature of the operator when it's being called. So I know that this operator is supposed to be a member of A. Therefore, it's going to be A dot function name receiving B. So that tells me what the operator looks like when I want to implement it. And returning it, we already know. Therefore, I go to my container, which is here, and in here I'm going to say this function of mine, whose name is operator right, it belongs to container, which means it belongs to A. It returns an int, that is the amount that is moved, and at right side it receives another container whose value need to change. Therefore, I have to pass the container and a reference so I can change it, and I'm going to call that one other. Now, to implement this, all I need to do is to say other m value will be equal to m value that I have. So it pours all the value of the left hand operand into the right hand operand, then makes the left hand operand's value 0, which means now the left hand doesn't have anything, and then return the value that was moved. Now my operator is implemented and it has a meaning. Therefore, this is going to work. So I'm going to say over here, cout, trying to move A content to B. A content to B. Okay, so now that it is called, I'm going to say moved amount moved from A to B, and I'm going to say over here A has the value. Oh, I don't have that in here. We don't have anything to print the A. Sorry, I have to do something in here. What do I need to do? What do I need to do? Display. I have to put display. So in here I have to remove this. We haven't learned how to do that yet. So in here I have to say a.display cout b.display, and nobody was saying anything. What the heck you're doing, Farhad, over there? Okay, and that's gonna go to new line. We're fine with that, and this will work too. We saw that last time. Okay, and in here we're gonna have a.display and b.display. Okay, so now if I run this program, oh, it's not going to run because it's not in my main. Give me a second. Sorry. Sorry. Stop. I'm editing the wrong file. Copy. I'm going to put it in here. Let's come down. All right. So now let's run the program and see how it works. Builders, no. Let's see what is the problem. Container yada yada already defined or declared. container operator minus equal. Oh, we've already done a minus equal somewhere that I missed. Yeah, we did a we have two minus equals. Let's remove that one more time. Okay, so let's put this one at left and this one at right. Can you see the fonts on the screen? Is it
Yes.
readable? And let's
Yes.
see.
Yes.
Let me others answer too. Yeah, that's perfect. Okay. So now if I run the program now, well, we'll see that A is created because it's assignment at the moment of creation. The constructor will be called. It goes to one argument constructor. The value will be 20, and therefore A will be 20. And B, nothing is passed to it, therefore default value is called. For those people who said you don't have two argument constructor, it's the same over here. So it has one argument constructor, but because it has default value, no argument constructor is called too. And that will be 0. And amount moved will be garbage. Then it shows the date for today. Then it says trying to move A and shows A content to B, that is 0. So trying to move the 20 content of A to 0 content of B. Now amount move is called. So as you see, operator extraction will be called that belongs to A. So goes up to the operator. Other over here will be the new name for B. This, which is the current object, will be actually A. The value of B is 0. The value of A is 20. It's moved. Therefore, now B has 20. A has 20 as well. Now we remove the value because we moved. So A will have 0 and it returns 20. That is the amount. And that 20 goes back to the amount moved. Therefore, it's going to say moved 20 from A to B. And it should displays A that has nothing and B that has 20. Are we okay with this? Mohammed, are we okay with this?
Yes, thank you.
Okay, good. So this is essentially an example that doesn't exist in regular standard operators of C language. In C language, we never have right side effect, but because we are overloading it, we are the master. We can do whatever we want. So therefore, this will be the operate with right side effect. Right side effect. Right and left. Okay. That's that. Let's go back here. So now we know the signatures for them. Unary prefix operators. So these are binary operators, left, right, and everything. And unary operators were pretty simple too. We said because they only have one operand, they're always members. So again, remember, these are general a member operator. Binary, remember, member operator. And this one, it will be general signature for unary prefix member operators. Now the reason I put capitalized member is that we'll come to it soon, don't worry. So I'm gonna put this thing over here. So if I have A is equal to minus B or A is equal to not B, the general, and depending on what it returns, if it's C is equal to something like that. Oh, actually, no, this is unary. This is unary. Never mind. So all I have over here is A type. So it returns an A type. Again, it could be a regular A type or a reference depending on how B is implemented. We don't know. So it's going to be A type and then B that is B type, operator minus with nothing in it. Okay, so without side effects. So these are without side effects, and the example for the other one will be not. And if it's without side effect, then I have to enforce it by putting const over here. So these are the signatures for it, and that's how it's done. We have done it in here, so I'm going to bring it back and show you. So without side effect, I didn't do anything without side effect, did I? Let's remove this. Yeah, so let's do the minus one. So if I want to say a container, I want to reverse its value, so I want to overload the minus one. So what I need to do, as we have seen over here, let's split the window. As we have seen over here, we said this is going to be the one. We want to overload the minus, so it's going to return a container. So I'm going to say container. Now, it doesn't have side effects, so I cannot return a reference because it's not going to, it's has to return a copy of whatever we have. So I have to create an operator minus const. Now I need to overload it. So I have to create a container to return, and that container should have the negative value of the current value that I have. Okay, and then I simply say return to return. Done. So now this minus returns a container which has negative value of what I have now, and because it's const, it's not going to change me. So now let me save this. I'm going to take it out. X. Binary with right with binary with side effect. Okay, so that's binary with side effect. Let's bring up another one. Okay, so now let's go back in here. I'm gonna remove the garbage stuff we don't need. Gonna come back over here. So that's what we implemented. Now I'm gonna remove all these. Now I simply would say, actually, I'm gonna remove these. Okay, so now A and B's are displayed, and what I'm gonna do in here, I'm gonna say B is set to minus A, and again show them. So if I run this, you will see that it comes over here. Essentially minus A calls A dot, so what it's going to call will be B is set to A dot operator minus const. This is what it's calling. So it calls that one. Return over here is some garbage. We're just gonna it's gonna create something out of 20, which is minus 20. So to return will have minus 20 in it, and then it returns the value and it overwrites B. Therefore now if we look at the output, we will see that A has the value of B and CNT has the value of 20. And I have to fix that thing that's not good. So in here I'm gonna correct it like this. I'm gonna put CNT and do like this. So that's a better looking output. So let's run it one more time. So when it runs, I'll see that A is 20, B is 0. After it runs, B becomes minus 20. That's unary operator with no side effect. Are we okay with that? Gustavo, you said no to the previous one. Again, if you're saying no, you have to please activate your microphone and talk and tell me what the problem is. Just responding to the poll is not enough, okay? Because it's another screen and I don't see what is over there. So please just activate your microphone and tell me what's going on. Gustavo, you had problem with the previous one? Gustavo is not here, not answering. All right. So are we okay with what I just said? Now this time I have to wait and see if there is a no in here. And I'm not going to wait for a long time, so you have to respond as soon as you can. And so for me, no news is good news. When you're not saying anything, either you've gone somewhere and you don't look at the screen, or you just don't see you have to minimize and maximize and so on and so forth. By the way, you know that you can change your status over here, so you can respond to me that way if that's easier. But again, you can't see it. So if you want, you can just uh, click and you can set. No, it's not set yourself as a way. What was it? Cancel, cancel, cancel. I forgot. I wanted to see how can I change my status, and no, it doesn't work. Anyways, I don't remember it. We used to. Oh, it's at the bottom. I forgot. So it's at the bottom. If you want to change your status or send me a thumbs or up or down, you can do it over here. Click over here and you say, for example, I'm happy, and that's going to be happy, or up or down and things like that. So I can see what your status is. Thumbs up or thumbs down, things like that I can see, and then and clear yourself by clicking on it again. So I can see the response, and it's going to be gone afterwards. So that's that. So this is the unary operator without
Professor,
side.
you're muted.
Oh, when did I get muted? I don't. Hey, sorry about that. Are we good now? 1, 2, 3. 1, 2, 3. Can you hear me?
Yes.
Okay.
Yes.
Yep.
Yes.
All right. So what I was saying is that you can change. Thank you. Yeah, you can change your. You can click on the reactions bar and give me thumb up or thumb down, but give it like 5 minutes, not 5 minutes, 5-10 seconds, and then remove your thumbs up for the next one, or the next time that I'm asking, you can change it back to a thumbs down if you want. All right, and you can raise your hand too if you have a question, and hopefully I'll be able to see it. Okay. All right, Anderson is happy, and I'm happy too. All right. So let's continue with unary operators. We have done the unary operator, and that's that. Yeah, and unary operators with side effect is the exact same thing. We've done it before. So the plus plus over here, as you see, this is a unary operator. This is the prefix one. And we said the only thing that was fishy over here was the postfix one. So we know exactly what these are. And the general signature for prefix operators with side effect is this: they don't have what shall we call it? They don't have constant. So in here, I'm going to put an @ sign to generalize it. Same thing over here. So this is the general signature for a unary operator that has side effect, and the postfix operators that have side effect. We said there are only 2 of them, so I'm not going to put an @ sign or placeholder for it. That's what I will have. So essentially, I'm going to write over here something like this, and in here and I put an int over here. So int and int. Okay, and that's that. So that's the int operator, postfix operator. You put an int over here. Int doesn't mean anything. So int is not an argument and only means postfix. Remember that, okay? It's extremely important to remember that. Do we understand that? All right, so when that's the case, then that's going to be the postfix operator, and we're good. Then we talked about index operator and top typecast, and we said we can have typecast operator, which essentially converts one thing to another. So say I wanted, I think I've done that over here already. Did I? Did I do typecast operator? Price operator minus plus 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 equal display operator. No, I didn't do it. So this one is going to be C and post unary operators.cpp. Okay, let's bring back this one. We don't need to be, I am doing reviews, so I'm going to just remove those things that we had from last one and bring back the CPP, and we'll continue. So say I want to do this. I want to write, so we know that we can with assignment operator, because you have overloaded the assignment operator with an int, if you write over here b is set to 200, it will pick up the assignment operator and 200 will go there. So essentially what happens is that if I go over here, see out b.display, it will show 200. We know that because it calls the 200 operator unary binary operator and sets b to 200. Are we okay with that? But let's go backwards. Let's say, what if I want to say integer value, and I want to say value is equal to a. I want to, when I do this, I want this a to give its integer value out when this happens. So when I write something like this, what the compiler would do, remember, like please answer this. This is a question that I'm asking. So if I have over here integer a, and I have double b set to 2.55, if I write over here a is set to b, my question is, what happens when line 76 is reached? What does the compiler do? And the person who's going to answer will be, you have your name on a screen, please answer. Do not chat.
Sorry, pass.
Oh, thank you. Yes, go ahead. So what's
pass, sorry.
Sorry, one more time.
Pass.
Pass? Okay, pass. So now April is going to answer. At line 76, when at left side I have an integer.
Typecast.
Okay, typecast. Yeah, it's going to be a typecast. Thank you. So what happens is that b will be casted to an integer, and the value of a will be 2. We know that from C. Are we okay with this? Okay, so we want to do that. What I want to do to happen, I want to tell to the compiler when such a scenario is happening, and at left side I have an integer, and at right side I have a container. I want that container to be casted to an integer and the value of the content to come out. If I want to do that, I need to overload essentially this, something like integer. And as you see, this cast doesn't exist. To make this cast overloaded, this is the signature for it. So essentially you are writing operator integer, because when you look at it, this int over here is essentially like a unary operator at left side of the container. So you write operator int, and you don't need to write a return value because the type it's being casted to dictates what is being returned. So all I need to do is to do this and write here return and value. So this essentially says if the container needs to be casted to an int, run this. Okay, so now if I come to this point, so let me show you what happens over here. I can say see out the value of a is, and I'm going to show the value. And I don't need this double schmubble thingy over here. And b.display, this is all we need in here. So now if I run the program, we will see that it actually comes over here and runs the operator and returns the 20. Therefore, value will be 20, and it's going to tell us that the value of a is 20. Are we okay with this? All right.
A question.
Yes.
What happens if we don't use int before a
That's
capital?
exactly what I wanted to talk about now. What happens if I say value is b? See out the value of b is. The answer is the exact same thing happens when you are using integers and doubles. C++ compiler is smart enough to detect that at left side it has a type and at right side it has another type, and there is no way to convert these two together. So it tries to cast b. As soon as it wants to do that, the cast operator will be called type conversion. So essentially this is called literally type conversion operator. So now if I look at this running, you will see that not only for the first one it is called, but when it comes to this one, it will be called as well. Are we okay with this? All right. So that's that. Okay, so now we have that. Now we have the unary operators are covered. Typecasting is covered too. Let's go back to the so this one is going to be uh, D type conversion overload. Okay, now I'm going to bring back the int array that we had over there. And as you remember, we had over here an element that we had. Remember that? Oh, why is it doing this? Is uninitialized. What is uninitialized? M garbage. Oh, it says M garbage is initialized. By the way, you can initialize everything inside your class. So it's always a good idea to do this. So essentially you say, I want everything to be null, but I start. So even if you don't have a constructor, everything will be set. So in my .cpp over here, I am setting all these things to null. Because I'm setting all these things to null and they are being set null over here, it makes this default constructor moot because I already have done it in here. Let me just put it at right side so we can see what I'm talking about. So you can initialize the values, the attributes of the class right inside the class. And the constructor over here, the default constructor is the no argument constructor, is actually setting them to null. So if it's a redundant thing and you could just remove all this and say, I want an empty one argument constructor, which means everything is already set to null in the class. Are we okay with this? And that is why I ask you to please review what we talked about last time when you come, because I'm going to pick up from the old one. If you did not review and this is serious, people, if you don't review the thing that we've talked about last time, we don't have time to go through everything. Okay, so please review all the things that I've done last time before the next class. So remember I was talking about the curve of forgetting, and I said that as soon as the lecture is over, the day of lecture, you have to spend 20 minutes to go through what I've done, and then a week later you have to do 10 minutes to go through everything, and a month later 5 minutes. The 10 minutes that you're spending on it for the week later, do it before the day before the lecture. So make it 6 days instead of 7 days. And the 10 minutes that you are reviewing what I've done last time, do it the day before the lecture through the notes, and then you remember everything and you're ready for the next lecture. Can I trust you to please do that? I want to see how many of you is going to say no. Anyways. All right. And Ali, are you here? It's completely, I don't know, mute standing over there. You never respond to anything. You just came in and that's it. Okay. It's not here. Can't do anything. Okay. So Paul, Natasha, Grace, Darren, Ali, these are people who are not responding, which is okay. All right. So now listen to this. If your constructor, for any reason, default constructor, no argument constructor, is empty and you don't need to do anything with it, you don't need to write it. You can just remove it. And in here you can say that means compiler, please create an empty one for me. So instead of actually writing it, you go to the definition and you say, hey, create a no argument constructor, an empty one for me. I don't want to code it. Please do it for me. Are we okay with this? Do we understand this? All right. So now that we are here and we've done this, and in our main for, let me just bring up the main that we had for it from the last time. Main. This is int array main. Copy. So this is the int array main that I had with all the good stuff that I've written in it. I'll remove all the things that we have, and it's 09 February 11 now. Okay. So now let's take a look at what we have done. We created over here two methods. One was element that returned the reference of the current index, as we have done it over here. And I put two return statements. One is garbage and the other this one. and I said we can actually change this using a pointer. So to not to have two return statements over here, what I can have is to create a temporary pointer that points to garbage and reset it to the other one. So to overcome this, I can actually write integer pointer, and I'll call it that's what's going to be returned, and I'm going to set that one to address of garbage. And then if everything goes good, I'm going to change that address to address of the valid element. And instead of having two return statements, I can say return target of ret, which essentially becomes the, so this will be either the reference of garbage or the reference of the valid element, depending on how the index is selected. And we do the exact same thing over here. So what do I do? It's actually the exact same thing. I'm gonna just copy that. But this one has to be a constant integer pointer because it's not supposed to change. So that is the difference between the two. Here, this is not constant. This is constant. Therefore, it has to be a constant integer pointer. Are we okay with this change? All right. So that's that. Let's go back over. See if you write something in public chat, a message. Oh, I see that Ali says I'm just listening. Okay, so all right. I speak up. It's good to hear your voice every now and then. If you put something in public chat, I don't see it because I have the poll open. So just for you to see, this is what I see because I have the poll open over here, and I'm going to say over here answer, and in here I'm going to put yes, no. So I'm going to say, do you see this? And I start the poll and you answer the questions. And this is when I hear your responses. I don't see any chats. So please remember, if you have it, Leo says no. Funny you are. All right, so that's that. All right. So I'll go back over here. And what else do we have? We have the element over here, and that's that. So it's 11 o'clock. We have 35 minutes. I'll give you 5 minutes break. Stretch, have a glass of water, something, and exactly at 11:05 I'll continue. Please be here. Don't be late. Okay. I'm going to pause the recording. Please remind me to continue recording after I'm done. Recording over here. All right. So let's continue. So we created two methods over here for the element, and it returned the reference of the element. But if we come back over here, we see we have a beautiful thing that we can actually do. Oh, let me just do the type conversion operator. So I'm gonna say A is, I'm gonna say over here B type operator. So essentially the type conversion operator for this will be B type operator A type const. Okay, yeah, because we are not changing. I made a mistake over here. I didn't put the const, because if you don't put the const over there, you're essentially you possibly will change the owner when you're not supposed to. So for this one, I should have put a const afterward over here. Otherwise, I may change the owner by mistake. So this const is a must, and I forgot about that. So that's that one. So that's the operator A type const. So that's type conversion operator. Now for index operator, this is what it is. So if I have A and I have B type over there like that, the type conversion will be A type. Sorry, the index operator will return an A type. It belongs to B type because it's a binary operator. B is the left and index is the right. And in here it's going to be operator index, and you pass to it anything you want. So anything you want. In this case, it's so let's actually put over here a C. So in here is a C type. C type, C type, C type, C type, C type. Yeah, a C type. So, and depending if it's wanna be, so this is with no side effect. So this is with side effect. This is with side effect. And which essentially changes the owner, that is B type, or you can have it without side effect. That is essentially the same thing with a const. So this is without side effect. Now let's take a look at our integer array. We had over here an element. So all I need to do over here is to just change the name of the element function to operator index. And the same thing over here, exactly like what I have written over here. So in here, I'm going to change the element again to operator index. And come back over here, do the same thing. So this is operator index and operator index. So if I do this, please pay attention that the only thing I did over here was renaming the element function to operator index. Are we okay with that? Now that I have done that, let's actually take a look at our main and see what happens. So in here, I need to change the element to operator index, operator index, operator index, operator index. Do we have anything else anywhere? Operator index. And if I run the program, it would run perfectly as we did before. So as you see, everything is running and everything is good. So C index overload. They call this one subscription overload too, but I call it index overload. Index overload function call. Okay, now I'm going to go back in here and I'm going to say, wait a minute, since we overloaded the operator index, you can simply remove the operator function call and use the operator index instead. So I can just take this and put the index operator around it. Take a look. See, now it's actually getting to look like an array. Take a look. I'll take this and I'll put index. I hate this new feature of all right, let's do it like this. 5, and the same thing over here. So this one's gonna be now, as you see, my int array looks exactly like an array now. So I say, if I just say, why did I say A10 over here? A10, what was this thing? Let me look at the previous one. Oh, I don't know why I just called this. It's kind of stupid, but anyways, remove that. There you go. So now if I run the program, you will see that it comes through over here, and when you say b index 5 is 500, it goes to the operator and does exactly what the operator is supposed to do, which is returning the reference of index 5. So the reference of index 5 will be set to 500, and therefore 500 will be printed over there. And one by one I can set it, as you see, and every single set that happens actually goes over here, returns the reference of the corresponding index, and everything will be set to the values I want. Oops, let's go back. Can I go back? No, I can't. So when you actually call the display now, because it's a constant one that is being called, when it comes over here, that was the empty one. Let me go to this one again one more time. So when we pass the object as a constant reference over here, therefore I becomes a constant object, and now when the index operator is called, automatically it's going to call the one that is constant, and therefore it is not going to change the value, and it is safe to use. And after executing the whole thing, you will see that all the values are printed. So now our array looks more like an array. Take a look at it. I have an array and I set it, and the good thing is that when you pass this array to a function, you don't need to pass its size or anything like that, because it contains all the information within. Are we okay with this? All right. Now that we have done this, we need to see. So now you have seen all the operator overloads that you can do as members, and this is always a priority. You should always try to make things as members. And let me just I'm going to CDE index operator overload call.cpp. Okay, so you should always remember that at any moment of time, if you are to overload an operator, you should always try to make it a member. Always, always. But sometimes you can't. Let me show you. Let's go back to our container. Okay, so I'm gonna come back over here. All right, so now I'm back in. Oh, this is the array one. I didn't want that. I wanted to. This is the container. Okay, copy. So take a look at our container. Okay, first of all, to make things organized and not to have it like this, let's convert the container to a class. So what I'm going to do in here quickly, I'm going to come over here, right click over here, I'm going to say add a new item, and this is going to be a class. Oh, it's going to cause trouble, I think, because I already have a class in this here. In here I have to copy. Yeah, so because in my main I had the class container, it wouldn't allow me to add one. So I'm going to add a new item, and I'm going to add it as a class, and I'm going to call it container. So automatically it creates the module for me. Container H, container everything. We don't need any of those. I'm going to click OK, and voila. So I have the container class as usual. What I will do over here is go, if not define, Seneca container H, and put over here define and bring the class container in and put it in namespace Seneca. Since I'm actually doing a proper module, let's actually do it proper. Now I'm going to go back to .cpp. So let's put the header file at right and put the cpp file at left. Okay, and in here I'm going to say namespace Seneca, and this is my empty module. Again, remember, this is one of the questions for your midterm. So now that I have this, I'm going to bring the container class. So the container class is, I think this is the one. Yeah, so what I'm going to do is remove all these, and I'm just going to convert all the functions I created to prototypes, as you see. So these are all prototypes. I want to have actually the class separated from the implementation. So everything is going to, so we have an O stream. I need to include IO stream, but because we are in a header file, this has to be std, otherwise it won't work. So that's that, and this one. So I just cleaned it up so we can see exactly what the prototypes are, and then they're separated from the condition, from the implementation, and it makes the code much more clean. This is a kind of better to see. Okay, and I'll remove all the implementation and main and everything over here. So this is gone. Let's take a look at it. That's my container, whatever I created. Beautiful. Now I'm going to come back in here and actually create the, so in here I need only the methods. These are all removed. Main is removed. The reason I'm doing it in front of you, so you can see exactly how to convert something that you design as a practice to something actually that's properly done. So I'm going to take the name of the class that owns it, add a scope resolution, and keep going. So copy, that's going to be my, I'm going to copy this, copy, and add it over here for this operator, add it over here. We don't need this. This is a prototype. Operator, operator, operator. Wow, they're all operators. Operator, display, and operator, and where's my type conversion? Did I copy an old one without type conversion? I think I did. Yeah, I'm going to add the type conversion. So it was operator int const, easy. And I want to create it. I go to the screwdriver and I'm going to say definition in container. It's going to bring it over there for me quickly. I don't have to do anything. And I'm just going to say return and value. There we go. So now I have almost everything in here implemented, nice and dandy. Bring it up here. By the way, when you are designing something like this, it's a good idea to go right before the thing. You see that? If you just, on Visual Studio, you do /3 times, see what happens. 1, 2, 3. It creates a summary for you like that. So you're going to say over here, adds the value of other into the current container. Okay? Oh, no. Returns a new container with the sum of values. Then you come to parameter other over here. You're going to say container. Const container reference and returns a container. When you do something like this and you add it like that, what happens is that at any moment in your program, if you actually hover over it, it actually shows you the information. Oh, a name was started with an invalid character. What did I do? Oh, probably I put an ampersand over here because it's XML. You can't put ampersand. How do you do HTML ampersand? Anybody remembers? It's anybody remembers? If you want to write ampersand in HTML, what do you do? Anyone? Nobody passed Web222 or something, for heaven's sake? Really? There you go. So I think was it? I don't remember what it was. I think it was.
I think it's the ampersand sign and then AMP.
Ampersand sign AMP, something like that.
Yeah.
Let's see if it works. So I hover. There you go. Thank you. Yes, perfect. All right. So now it says other is constant. So it gives you a help of the function that you have written. You see this? It's so comprehensive and beautiful. So adding comments like that helps you to actually see what happens, and you can comment it perfectly like that, and it's used everywhere. Thank you very much. Who answered that? Who answered the ampersand thingy?
Kushil.
Okay, Kushil, you have 1% for your midterm. All right. Had nothing to do with C++, but thank you very much for answering. All right. Put me out of my misery. Okay, so that's that. So now we have learned all these good stuff, but sometimes in our main, let's say in our main over here, I'm going to write, and I think something else, it has to be added to the container because IO stream is already here. I have to remove it and put it in here and bring the container down. Save it. That's better. So in here, I'm going to say include IO stream because probably I'm going to use it. And I'm going to say over here, include container. The reason I separated it is that it's becoming too big. I don't want it to spam our pages. Using namespace std int main, and I'm going to return 0. Now, it's all fine and dandy if I want to add a value to a container, and like for example, if I want to write something like this, I want to write container, and using namespace Seneca, I can write container over here, A and B as 30. Maybe I want to write A is equal to B plus 3. Okay? If I want to write something like this, we know that it's not going to work. We know that if I want to have something like this, compiler requires this. So a container to be returned from a container with operator plus that accepts an integer value. So I need to have this, otherwise it's not going to call it, because this plus essentially, so the operator call will be for it, a is equal to b dot operator plus an int. Oh, sorry, 3. So something like this. Creating it is 2 seconds. So literally is actually something like this. So it's essentially something that doesn't have a side effect. That's the only difference with that operator plus that we have. So I'm just going to copy that and put a plus in here. So that's the one. And in here I'm going to say const. So that's the difference between the two. It doesn't have a side effect. And if I actually run this, you will see that it creates the exact same thing. All I need to do is to create a container, returning a reference a mistake because it doesn't have side effect. I have to create a temporary one. I cannot return the current one. So I have to create a container, return that has value plus m value as its value, and then return ret. Okay? So now this will actually have a meaning. Why is it not giving me a, b plus equal container? No, it should be good. I don't know why it's giving me error. Save it. Similar conversions to what? Let me see. Did we create 2 of them?
I think we have 2 of them.
No, we don't have 2 of them. This is what happens. So it's a beautiful example. This is the problem. You see this? Because I already implemented this and I already implemented the cast overload, it already had the stuff to create one. Let me see if I remove it, it will work or not. Const, but this is not const. This is supposed to be const. That was wrong. So let me fix that. Where's the other one? This is supposed to be const. We have that one, but it gets the value of the other one. It is, there we go. That was the problem. See, that's why it's important for you to follow all the const stuff that we have. Now I'm going to go. So the implementation that I had still build errors. Let me see what's getting. Redefinition of parameter 1. Oh, sorry, I only on the, I copied it and I brought the default value. The default value is supposed to only be in the prototype. One more time. There we go. So now if I come over here, now it actually goes to that receives a value and creates it. The difference between the two is that this one receives a container and this one receives a value. So there's a difference between the two. Okay? And because I didn't put const over there, it was getting confused what to call. None of the signatures matched, so it didn't know what to do. So now that I have const over here, it knows exactly which one to pick up. So this is working properly. And if I do, we have 1 minute left, and we have, and it works and everything is good. But the problem over here is, if I write something like this over here, shoot. Okay, the time is up. Remember where I left off? We'll come back the next day. Please review all the things. Actually, a good thing that I didn't get through this. We went through all different types of member operators and everything was done through, completely covered. The next day that you're coming in, we are going to go through completing everything about operator overloads. And I want you to please review this before the next day you are coming in. Can I trust you to do that, please? All right. So I'm just going to commit it to the repository right now to make sure we are not losing it. So commit. I'm going to say member operator overload completed. Commit. And we're all set and done. Okay, the recording is going to be ready on the big blue button in matter of minutes, and upload is going to happen within a day. Have a beautiful day. I have to start the next session for OP345. If there is no question, I'm going to end the session. Any questions? All right, thank you very much. Have yourself a beautiful day, and I will see you in class on Thursday, I believe. Have a beautiful day, everyone. Bye-bye.
Thank you, Professor. Have a good day.
Have a beautiful one. Bye.